Okay, last problem for this set of mixed modeling. We have a right circular cylinder of height h and radius r. It's inscribed inside a cone with height of 9 centimeters and a radius of 3 centimeters. Express the volume of the cylinder as a function of its radius. So think about what your volume formula is for the cylinder, and jot that down. And then what are your pieces that you have and what do you need? So in this one, we're going to have to figure out the height in terms of radius. Okay, so that's what we're asked to do here. So that height you want to solve out to get an expression involving r. So I'm going to draw the diagram here. First, I would have, let's see, my little pyramid or cone, not pyramid, and I would have then my cylinder in there. Let's see how good I can get this drawn here. And I'm dropping down and kind of the bottom there. And then I have this radius in the middle, and that's going to go out to the edge of the cone. Okay, and then I have this top part here. Would be my height. So I know several things. I know my volume, but I want it in terms of r. So I'm going to say V of r equals pi r squared h. But now h has to be swapped out for something including r. All right, so I'm looking for the volume of the cylinder. So what I'm missing is this piece right here. Let's see. Let's make that a different color. This chunk here, if I knew that, then I could figure out, I could get that in terms of r, then I could work it all out. So a couple things that will help me is I'm given, let's just look what I'm given. I'm given the height of the cone is 9 centimeters. So this whole piece here is 9 centimeters. This big purple line there. So I know this is my h, my height of my cylinder. That's what I want to get in terms of r. This little piece here would be 9 minus h. I might need that. Kind of how we've done before, just kind of setting up our pieces and labeling things. Sometimes that helps us think about it. This little radius here, I don't know. So I'm going to call that r. That's the radius of the cylinder that I need to get in terms of. So I'm going to label that r. I do know the radius of the cone, so that one is 3 centimeters. So what do I have to work with? I do have similar triangles here. That might help me kind of set something up, right? So I have this big triangle. Right there, and I could figure out if I know that, is the, if I say the height, it compared, I'm just going to say height, do that down here, height of large triangle, okay, so I'm going to call this large triangle, the height over the radius, because what I'm trying to figure out is the h here. So I could use that as 9 over 3 and set up a proportion to the small triangle that I have right here, and that would be equal to my height on the small triangle would be 9 minus h over r. And that would help me get this r worked into h. So if I cross multiply there, I could do 9r equals 3 times quantity 9 minus h. Then I would have to solve out for h. So I would want to distribute this. So I would have 9r equals 27 minus 3h, and then I would subtract 27 from both sides, equals negative 3h, and then divide through by negative 3. Actually, I could have done that earlier on. It would have made it a lot easier. Let's do that. I'm just saying really a quick way to do this. Instead of distributing, I'm just going to go ahead and divide both sides by 3. So I'm really just going to clear the denominator there. And then I would end up with 3r equals 9 minus h, and then subtract 9 from both sides. 3r minus 9 equals negative h. So then positive h would be, multiply everything through by negative 1. I would have negative 3r plus 9, or even better, I could write it as 9 minus 3r just so it looks a little nicer. And then that could go up in here for h. So then I would have v of r equals pi r squared quantity 9 minus 3r. And I could distribute that out if I wanted to, but that's fine. You don't need to do that. You can just leave it right like that. And then the domain would be anything from 0 up through 3 on that one, because that's as far out as you could go. Looking at the radius start to finish on the cone, I wouldn't be able to go past that. That would be my max. So a reasonable domain would not go past that. All right, so thanks for watching. I hope you're getting used to looking at things with different viewpoints, like using the Pythagorean theorem. If we just have like one triangle and we need to know part of that triangle. This one was a little trickier because we had to do similar triangles, but if you look closely, you can see the two different triangles, one within this small one, within the larger one. It's a little bit different approach on that as well. So I hope that helps. Let me know if you have any other questions. Have a great day.